Cordial greetings everyone, especially to our professor, Mr. John Patrico Galesco. We are excited to share our work with you. Let me start by introducing myself and my group mates. My name is Shane Marian Datulia.
I'm Devera. I'm Asuncion.
I'm Nika May Bachansila and we are 2 CSA.
Dangal greetings. We have here the Smart Inventory System. It is a simple yet efficient program designed to help manage products and sales using a double linked list data structure. It allows users to easily add, view, update, delete, and search for products through a menu-driven interface. The program starts with Import Java Util Scanner, which lets it read user input. The main class, Smart Inventory System, contains everything the system needs. It uses two double linked lists, one for storing products and another for sales. A scanner is used for input and a counter keeps track of each sale. Inside the main method, the program first calls preload dummy data to load sample products for testing. Then it shows a menu that lets the user choose between product management, sales management, report, or exit. The user choice is read using the scanner and the switch statement directs them to the correct menu. The loop keeps showing the main menu until user exits. The preload dummy data method adds 5 example products like Coca-Cola and Skyflakes to the list. The product management menu displays another menu where users can add, view, update, delete, or search products. It uses a loop and a switch statement to handle each choice. The add product method asks for the product's ID, name, quantity, and price, then adds it into the list. The view products forward and the view products backward methods display all products either from the first to the last or in reverse order. The update product method searches for a product by ID, then lets the user change its name, quantity, and the price. The delete product method removes a product from the list using its ID, and the search product method finds and displays a product by name or ID.
Let's look at the core sales management features, where the sales staffs record daily transactions. First, recording a sale. To record the sale, the user selects option 1. The system first asks for the product ID. Once the product is found, it prompts for the quantity. If the quantity is less than or equal to the stock, the sale is immediately decreases the product and increase the sold count for reporting later. A new sale object is then added to our sales list. If stock is insufficient, the system provides a clear error, not enough stock. Next is viewing and deleting sales. The system allows users to view all recorded sales by simply iterating through the sales list for administrative tasks. Option 3 allows sales to be deleted using the unique sale ID. This function searches the list and removes the matching record, ensuring the data accuracy. The Reports and Analytics section provides management with essential business intelligence, powered by 4 quick reporting functions. First is the total sales revenue. Option 2 calculates our total sales revenue. The system iterates through every record in the sales list, accumulating the total amount for each sale. The result is presented with precise currency formatting, showing the total revenue in Philippine peso. Second is highest selling product. Option 3 identifies our star performer, the product with the highest total sales. The system traverses the product list, tracking which item has the largest total sold value. It is highly useful for reordering decisions and marketing focus. Third is out-of-stock products. Finally, option 4. It helps maintain inventory health by identifying out-of-stock products. The system iterates through the product list and reports the name of any product where the quantity is 0 or less. If all product were if all product are fully stocked, it confirms with positive message all products are currently in stocks.
Now let's discuss about node.java. Public node type T. Node is a generic class and the T means it can hold data of any type, example node integer or node string. T data. This field stores the value of the node. T is the type parameter. Node type T prev next. These are references or pointers to other nodes. Prev points to the previous node in the list. Next points to the next node in the list. Constructor. Public node T data. This.data is equals to data. This.prev is equals to null. This.next is equals to null. When a new node is created, it's initialized with a given data value. Both prev and next are set to null since the node isn't connected to anything yet. Now, let's discuss about class product or product.java. Public class product, it defines a template for creating product objects. Int ID is a unique identifier, example 1, 2, 3, or any integer or any number. String name, the product's name. Int quantity, how many items are currently in stock. Double price, how much each item costs. Int total sold is equal to 0, how many of product have been sold. These are instance variables, meaning each product object has its own copy of this value. Public product. Int id.string name, int quantity, double price. This.id is equals to id. This.name is equals to name. This.quantity is equals to quantity. This.price is equals to price. This keyword refers to the correct object being created. This.id is equals to id means assign the constructor id. This method overrides Java's built-into string method. String.format is used to create formatted string that includes the product details. Modulus.2f means the price will always be shown right to decimal places. Now let's move on sales.java. The sale class modules a sales transaction. It represents one sale of a product, including which product was sold, how many units were sold, and the total amount of money came from that sale. In sale ID, a unique identifier, product, reference to a product object, the product name or the price, etc. In quantity sold, how many units of the product were sold. Double total amount, total revenue from the sale, or price times quantity. Public sale, this line, the sale ID assign the parameter sale ID to the object sale ID. Product stores the product object so the sale known which product was sold. Quantity sold records how many units were sold. And total amount is automatically calculates how many money was made from this sale by multiplying the product price by quantity sold. Public string to string. This line defines how the object is converted for human readable string. Examples: modulus d is equals to integer, modulus s is string, modulus .2f floating number with 2 decimal places.
Next is a doubly linked list. It is a powerful data structure that allows us to store and manage a collection of elements in a linear sequence. Unlike a singly linked list, each element in doubly linked list has a pointers to both the next and previous elements, making it easier to traverse in both directions. So let's get started. First, we define our doubly linked list class. The T indicates that this is a generic class, meaning it can store elements of any data type. T is a placeholder for the actual type, like integer, string, or even a custom object. Next, we declare three private member variables, the head, tail, and size. Head is the node will point to the first element in the list. If the list is empty, the head will be null. Tail is a node will point to the last element in the list. If the list is empty, tail will be null. Size, this integer variable keeps track of the number of the elements currently in the list. We initialize it to 0 because initially the list is empty. Now, let's look at the add method. This method adds a new element to the end of the list. First, we create a new node object called new node. We pass the data that we want to store in the list to the node constructor. Here's where the magic happens. We have two cases to consider. Case 1, the list is empty, head is equal null. In this case, the new node becomes both the head and tail of the list. We set both head and tail to point to new node. Case 2, the list is not empty. This is where we link the new node into the existing list. Tail.next is equal to new node. We set the next pointer of the current tail to point to the new node. This adds the new node to the end of the list. New node.perv is equal to tail. We set this perv pointer of the new node to point back to the current tail. This is what makes it doubly linked list. Tail is equal to new node. Finally, we update the tail to be the new node because it's now the last element in the list. Finally, we increment the size of the list to reflect that we've added a new element. Now, let's look at the remove method, which removes the first occurrence of a given data from the list. We start by creating a current node and setting it to the head. Then we loop through the list starting from head until the current is null, meaning we've reached the end of the list. Inside the loop, we check the data of the current node is equal to the data we want to remove. If we find the data we want to remove, we need to update the pointers of the surrounding nodes. Again, we have a few cases to consider. Case 1, the node to be removed is the head. In this case, current.prev will be null, so we update the head to be the next node in the list. Head is equal to current.next. Case 2, the node to be removed is not the head. In this case, we update the next pointer of the previous node to the point of the next node. Current.prev.next is equal to current.next. Case 3, the node to be removed is the tail. In this case, current.next will be null, so we update the tail to be the previous node in the list. Tail is equal to current.prev. Case 4, the node to be removed is not the tail. In this case, we update the prev pointer of the next node to the previous node. Current.next.prev is equal to current.prev. It is important to note that case 1 and 2 and 3 and 4 are mutually exclusive, so they will never be executed at the same time. After updating the pointers, we decrement the size of the list and return true to indicate that we successfully removed the element. If we reach the end of the list without finding the data, we return false. Finally, we have the three simple getter methods: get head, get tail, and size. These methods allows us to access the head, tail, and size of the list from the outside of the class. Now let's move on to our testing and debugging. Let's test our smart inventory and sales management system. We'll go through each of the main menu option and some sub-option to see if everything is working as expected. We'll focus on the common use cases and some edge cases to uncover potential bugs. First, let's explore the product management menu. I'll enter 1. We're now on the product management menu. Let's start by adding a new product. I'll choose 1. Now the system prompts for the product details. Let's add a new product. The product ID, let's say, is 106. Product name, instant noodles. Quantity, 50. And the price is 8. Okay, then the system says product added successfully. Let's view all products to confirm. I'll choose number 2 to view products in forward order. We should see our newly added instant noodles along with the preloaded products. Let's check, and there it is. ID number is 106, name instant noodle, quantity is 15, the price is 8. The forward view is working. This time instant noodles should be at the top of the list. And yeah, the backward view also works as expected. Next, let's update a product. Say we want to change the price of the Skyflex. I'll choose the number 4. Then the system asks for the product ID. Skyflex has ID 102. I'll enter that, and now it is asked for the new details. I'll just change the price. Let's keep the name Skyflex. The quantity is 15, then the new price is 12 pesos. The system says product updated successfully. Let's view the products again to confirm the price change. Then let's find Skyflex, and great! The price is now 12 pesos. The update function is working. Now let's delete a product. I'll choose number 5. Then let's delete the instant noodles. Its ID is 106. The system says product deleted successfully. Let's view the product list again to view. Make sure it's gone. Instant noodle is indeed gone. Deleted function works. Finally, let's test the search function. I'll choose the number 6. Let's search for Coca-Cola. The system should display the details of Coca-Cola. Let's see, and yep, it is found it correctly. Now let's try searching by ID. I'll choose the 6th again. This time I'll search for a product ID has 104. It should find safeguard, and it does. The search function is working correctly with both name and ID. But what if we search a product that it's not on the list? Let's try it. As you can see, the program prints product not found for an ID that doesn't exist, same as it does when you try to delete a product that isn't there. Okay, now we've truly tested the product management menu. I'll choose 7 to go back to the main menu. Now let's move on to sales management. I'll enter number 2. We're now in the sales management menu. Let's record a sales. I'll choose the number 1. Let's sell some Coca-Cola. Its ID is 101. Let's sell 5 Coca-Cola. The system says sale recorded successfully. Let's view all sales in option 2 to see if the recorded sale. We should see the sale record for Coca-Cola, quantity 5. And there it is. ID is 1, product is Coca-Cola, quantity sold 5, and total 175. Because 5 times 35 is 175. The record sales function works. Now let's check if the quantity of Coca-Cola has been updated correctly in the product list. I'll go back to the main menu in option 4, then the product management option 1, and then view product list option 2. Let's find Coca-Cola. The quantity should be now 15, initial the 20 minus 5 sold, and it is. The quantity is being updated correctly. Now let's try recording a sales where we sell more than the available quantity. I'll go back to the sale management main menu and choose record a sale. Let's try to sell Skyflix. ID is 102. We have 15 in stock. Let's try to sell 20 Skyflix. The system should print not enough stock, and let's see. The stock check is working. Finally, let's delete a sale. I'll choose the option 3. Let's delete the sale we recorded earlier. Sale ID number 1. The system says sale deleted successfully. Let's view the sales again in option 2 to confirm. The sales list should be empty now, and it is. The deleted sale function is working. Sales management seems to be working well. I'll go back to the main menu and option 4. Now let's test the reports and analytics. I'll enter number 3. First, let's view the total number of products in option 1. We should have 5 products initially. Added 1, then deleted 1, so we should have 5. The system prints the total products 5, which is correct. Now let's check the total sales revenue in option 2. To test this properly, we need to record a few sales first. I'll exit the program first. I'll go to sales management and record some sales. Okay, I've recorded the following sales. Sale ID 1 to Coca-Cola ID 101, price is 35 and total is 70. Sale ID number 2, Lucky Me Pancit Canton, ID 103, the price is 15 and the total is 45. Now I go back to the reports analytic and choose the option 2. The total sales revenue should be 70 plus 45 is equal to 115. The system prints total sales revenue in 115, which is correct. Now let's identify the product with the highest total sales in option 3. Based on our sales, Coca-Cola has 2 solds and Lucky Me Pancit Canton has 3 solds. The total sold values are being tracked in the products class. The system prints most solds product. Lucky Me Pancit Canton has 3 solds, which is correct. Finally, let's check the out-of-stock products in option 4. Let's make Coca-Cola out of stock by selling all 13 remaining stocks of it. Then go back to the reports menu and check the out-of-stock products. Now let's check the out-of-stock products in option 4. The system should list the Coca-Cola, and it does. The system should list Coca-Cola, and it does. The out-of-stock product report is working. We've tested all the major features, and now let's exit the system. I'll enter number 4. The system prints existing system. The program terminates gracefully. But what if the user select a number that is not on the option? As you can see, the product prints invalid option. And that's it for our testing and debugging. Thank you for watching.